Spotted today, in the wide wilderness of mathematics, is a creature many students fear, the quadratic equation. It is usually found hiding in textbooks, lurking near parabolas, and appearing suddenly in exams, without warning. But this creature is not here to harm us. It is not a monster. It is not a spell to be memorized blindly. It is a shape, a curve, a pattern that appears again and again in the real world. When a ball flies through the air, when water rises from a fountain and falls back down, when a cricket shot climbs into the sky, the path often forms a parabolic curve. In engineering, parabolic shapes help in arch bridges, where the curve helps guide forces smoothly into the supports. In car headlamps, parabolic reflectors gather light and send it forward in a focused beam. Satellite dishes, solar cookers, radio antennas, and parabolic microphones all use this same family of curves to collect light, sound, heat, or signals and focus them toward one point. So the quadratic equation is not just a classroom problem. It is a doorway into motion, design, light, sound, structure, and nature. But in school, many students meet it only as something to solve quickly. They memorize the formula. They fear the formula. And then they forget why the formula exists. Today, we take a different path. We will not cram the quadratic formula. We will watch it emerge. We will solve the quadratic equation by completing the square. Not as a trick, not as a shortcut, but as a piece of geometry being built in front of our eyes. We begin with the standard form, ax squared plus bx plus c equals 0. This is the creature in its natural habitat. 3 terms, 1 equals sign, and a suspiciously quiet 0. To study it more clearly, we first divide every term by a. The equation becomes x squared plus b over a times x plus c over a equals 0. Now the leading term is simply x squared. And that matters because x squared is something we can see. It is a square, a real geometric square with side length x and area x squared. To make the equation easier to observe, we rename the fractions. Let p equal b over a, and let q equal c over a. So the equation becomes x squared plus px plus q equals 0. Cleaner, simpler, less likely to bite. Now we move q to the other side, not because q has done anything wrong, but because it is standing on our construction site. So we write x squared plus px equals negative q. And now, the real lesson begins. The symbols are about to become shapes. The algebra is about to become geometry. And now, the symbols begin to behave like shapes. X squared becomes a square. Side length x. Area x squared. Simple, elegant, very well behaved. But px is different. Px is a rectangle, and one long rectangle cannot complete a square by simply standing there looking confident. So we split it into 2 equal rectangles. Each has area p over 2 times x. One goes along the bottom of the square, the other goes along the side. And suddenly, we almost have a larger square. Almost. There is one tiny missing corner. And in mathematics, tiny missing corners have a remarkable talent for causing trouble. Each strip has width p over 2, so the missing corner is a small square with side length p over 2. Its area is p squared over 4, so we add p squared over 4. But algebra has manners. If we add something to one side, we add it to the other side as well. So now, x squared plus px plus p squared over 4 equals negative q plus p squared over 4. And the left side is finally a perfect square. So we write x plus p over 2 all squared equals p squared over 4 minus q. That is completing the square. Not a trick, not a shortcut. A square genuinely completed. Now we solve. Take the square root of both sides. X plus p over 2 equals plus or minus the square root of p squared over 4 minus q. The plus or minus matters. A square may come from a positive value or a negative one. Mathematics, unlike some people, considers both sides of the story. Now move p over 2 to the other side. X equals negative p over 2 plus or minus the square root of p squared over 4 minus q. Beautiful. But p and q were only nicknames. P equals b over a. Q equals c over a. So we replace them. X equals negative b over 2a plus or minus the square root of b squared over 4a squared minus c over a. The formula was never the monster. It was the footprint. The footprint of a square we built ourselves.